Welcome, Larry.
Hey, thank you so much. All right, hey everyone, thank you for having me, and yes, it's awesome to be back. The sun is going away where I live in Seattle, and I lived here for a number of years. I had originally came to North Carolina, good gosh, a long time ago. My specialty before going into any computer science school was in character recognition systems. So I would use systems to read handwriting and characters. And so I was actually commissioned by the Department of Revenue here to redesign all the tax forms for North Carolina. And that was my first job, and I did that for a couple of years. And you think it'd be kind of boring, but it was actually kind of neat because you got really, really good at designing, and actually allowed me to pay like some of my college bills later on because I was so good at Adobe, Photoshop, and things like that. But what it was it got me into the idea like, oh my gosh, I didn't have a background in computer science. I'm like, how do I get ahead here? I've started learning how to program. I started messing with these things. So I went to night school at State because my undergraduate from Syracuse was in business. I was like, all right, I need to take some prereqs and go through the program. And then I ended up going through the Master's Computer Science program, essentially through night school and then full-time for a couple of years. And I'll tell you, I feel super, super excited about being here because the best thing that I got from my computer science program degree was it taught me how to think. And what I mean by that is it taught me how to attack problems because I was a business person coming in to a bunch of people that were in master's program that had undergraduate in computer science. And I was like, are you kidding me? I am destroyed. I'm dead on arrival. But it allowed me to hit these challenges and take on new things that I've never done before. I've done a number of things since then. Ended up leaving, went to do a sysadmin work up in Toledo, Ohio, out of all places. Not the most fun job. Ended up starting a company up making sporting goods, doing softball bats. And basically it was an entrepreneurial type element to it. We sold that off. I went to MBA program back at UNC. And then I was with IBM for about 11 years, doing everything from data warehousing through business development. And then the last 3 or so years was really getting IBM into the cloud and acquiring a company called Cloudant. And that was one of our first data services. Basically, it was a NoSQL data store. It was a document database based on open source. It was CouchDB. And did that for about 3 years. We built out a portfolio until I got to the point and said, all right, it's time for a change. And my wife and kids, we all picked up and moved out to work for AWS. So I'll leave this up to you as well. We'll go through the presentation. I got a lot of charts here. I don't have to go through all of them. Happy for Q&A. But also, if I don't get to anyone today, you have questions, you want to talk about anything, even just AWS or working, feel free to reach out. I'll give you my email address, and feel free as an alumni to just pick my brain if you want, okay? So, I should have gone through the agenda first. Let's go to introduction, a little bit of getting everyone on the same page with Amazon and AWS. Does everyone here know what AWS is? All right, cool. So I'll go through a couple of slides here. AWS was founded in 2006, and it's kind of scary to think that's the year I graduated my MBA program. And the company has grown crazy fast. And to the point where, the big statement up there, cloud computing is the new normal. It's our entire world. Our service has more than 1 million active customers every month in 190 countries now. It's pretty big, and it's growing quick. And through this presentation, I'm going to go dig in a little bit on the databases side, but there's a lot of different new business programs. There's new models, new development platforms that are being defined as we speak. I was getting a little worried as I was putting these slides together the last couple of weeks. There's already things that are outdated in here. Right before coming here, I'm a little out of breath. We actually launched 2 new products, and I was late getting here because it was like, Larry, we need approvals to get these things out. And it was MySQL 8.0 and MariaDB 10.3. And this happens all the time in massive, massive scale. The stuff is fast, blistering fast, but it's so awesome to be on the cutting edge of stuff that customers are asking for and wanting to build and put into market. On the right-hand side, look, a lot of our customers, a lot of folks, people are deploying apps in the cloud now, as default. When I was in business, when I was in graduate school here, we weren't doing that. It wasn't cloud first at all. Now it is. And we see a lot of net new apps and a lot of migration for those people that have built existing apps on premise that want to bring them into the cloud. So a couple of things we like priding ourselves on with customers, right? The number one thing here is a second bullet there. It's agility. It's the ability to do things faster, make quicker decisions. You're not going to have to sit and wait, weeks or days to get access to code. You can just go click on it, sign up, and hopefully everyone in here has done it before. But you can get access to databases, data servers, whatever you want at a glance, in minutes. And that's super great for companies and super great for people that want to innovate and do new business problems. The other thing here is, eliminating costs, trying to make it a little bit easier, more functional for people so that you have to spend all this money on new servers. You can just go in there, rent it out in the cloud as is. And the last one there is reduced risk, not having to do all that hard work on yourself. Like, let us do it. Let someone else take care of some of those hard things. On the right-hand side, just kind of quotes about our customers. With someone like GE, betting this on us, right? And people that are saying, hey, AWS, we want to be a part of this. Like, come on in, let us, work together and let you guys support our IT operations. Just to kind of show you real quick, we have a global footprint. This is the current state of affairs. We have 18 regions, 55 availability zones, and 121 edge locations. Is everyone familiar with what a region and availability zone is? All right, because the best way I think of it is like region is just like a general space. Availability zone are like the actual physical areas in there, and there's about 3 on average. So if I said the region was the triangle, one availability zone could be Durham, one could be Raleigh, one could be Chapel Hill, and those where the physical servers are located. The reason I bring that up is it's so important in some of our database areas because we leverage the heck out of all those availability zones for a number of different reasons. Performance, resiliency, backup recovery, all that kind of neat stuff. And we're just growing. Wherever there's demand, where customers are telling us they want us to be, we're moving as fast as we can. And then here's another one. And this is why, I seem a little bit out of breath here. It is a massive amount of innovation and the amount of new products coming to market. If you can see here, in 2010, we had 61 launches. In 2012, 159 new services. In 2014, 516, and then last year, this isn't even this year yet, the end of last year was 1,430 new services here. And that's crazy to keep up with, not just from a marketing standpoint, from a service perspective and making sure everything's up to date. And so we're going as fast as we can and listening to our customers and moving forward as best we can to cover these new services and new areas of growth. And just to give you kind of a snapshot on the world and where my view is, so I manage marketing or product marketing for our databases segment. Includes our relational databases, all of our non-relational databases, and database migrations. I know it's an eye chart, I'm sorry. You guys can get these charts afterwards and you can look at it here. But a whole heck of a lot of different things. Anything from analytics, AI, IoT, mobile, enterprise apps, everything in here. And then here's my view of the world in red, databases. It's a lot and it's growing. So let's get to the point of databases in general, right? And when I was looking at some of these charts and coming up with what I wanted to say, I really dated myself because I was like, oh my gosh, I graduated school before this stuff came out, and I remember when I would submit homework and stuff, it was dial-up modems. We didn't have everything wonderful super fast cable modems and all that neat stuff. And you would pass, if we did distance learning, it was via CD-ROM, and you would take it home and look at it. Yes, I am that old. But anyway, looking at the evolution of databases, where have we gone? Where have we come, and where are we at today? So 1970, EF COD, let's define what this relational model is. Let's look at columns and rows. Let's start putting it together and define structure for the relational database. But COD, working at IBM at the time, didn't have the effort, I guess, or the resource to actually come out with a full working database with IBM. Actually, Oracle beat them to the punch. And the first databases that came out around the 80s, or pre-80s for Oracle, then DB2 from IBM, and then Microsoft SQL Server, these were the main ones, the mainstays for a period of time. These are all relational databases and very focused on servers, in-house, very corporate, and we grew from there. Now, what happened from 1990 to 2000 were the emergence of open source standards. I mentioned before, we just relaunched on MySQL 8.0. These were still on premises, right? And this was before open source had the advent of cloud and other things we can get to in a second. So it took a little bit longer to emerge in open source. And I got to tell you, when I first started dealing with open source projects, when I was younger, it was a nightmare because I had to deal with either massive amounts of floppy disks, and my installs were always incorrect. I had major problems, and it was difficult, and it took a long time to accomplish something. But anyway, people kept at it, and these two systems really emerged, like MySQL going into LAMP stacks, and Postgres, I know for a fact Postgres was being leveraged a bunch in data warehouse appliances because people wanted to get off of paying all the expensive costs for all the different licenses and all the resources, and they said, let's use open source, let's bring this in, and oh, by the way, it's open, I can start forking it and working in ways that I want my database to be. And that was like the first time people were started really tinkering with things and saying, let's build something we want. And this gets into the end here. Anything from beginning of 2010 through today. It's a massive amount of data servers. You went from like a handful, and in the past, what was it, 2018 still? I forget. Like 10 years? Look what we've gotten. We have over 340 plus databases being tracked on dbengines.com, which is a site that tracks like which databases are the most popular in search terms. How do we keep up with that? Why is that being? Why do we have so many databases now? It's insane. And it's something very difficult to keep up with. For the existing companies, for let's say legacy organizations, oh my gosh, it's like they're eating everyone's lunch. At the same time, you have all these databases. How do we keep these all updated? And right, which one should I use? Which one's going away? We'll get into some of those in a second. But here's where the things changed, right? And I talk about the old days when I went to school to the new. Here's the traditional application requirements, right? Back in the day was you get users in the tens to hundreds of thousands, and things were local, right? It was really to your HQ or where you were working at the time, right? I remember when I paid my way through undergraduate doing warranty claims, which I had to physically handwrite them and then put them in an Access database. I think and it was just for a major corporation too, and I think it was a total of like 10 people leveraged this database. It was a different world, right? And things were actually siloed. They were in different camps. HR wasn't necessarily tied to marketing. It wasn't tied to other parts of the organization. It was expensive. If you wanted to scale, you had to scale up. What does that mean? You have to buy more hardware. Your department might not have the hardware. You go knock on the door of IT. Hey, can we have more hardware? They're like, no, we're already doing too much. And you're like, all right, can I go buy a computer on my own and do this? It was a different world. And also the other one here, I put it in the back end, is developer access. This is like before the developers were like a thing, right? Before people were really actually able to do this. It was days, weeks, or months. I give you a quick story of myself. When I said I was doing character recognition work, before I came and worked for the Department of Revenue here, I worked for a startup. This is like pre-internet revolution. And it was a device called OBOS. It was called One Button Ordering System. It was a little box, press a button, and it took an order form in and took a picture of it. It was a TIFF image. And so we have like hospitals, hotels, and other places would like, hey, fill out this form, press the button. It's pretty easy. You can't really mess it up. I would then basically engineer the software to read that handwriting from it and then put it into a database. I needed to get access to this, I forget the name, it was like some OCR for forms or something like that. It took me weeks, and I had to get CD-ROMs, bring it in-house, and then get a physical dongle to put on the back of the computer. There was no instant API. It was a nightmare. And then I had to get this thing in here and actually learn how to use it, and if the manuals weren't up to date, I didn't have something to go online, I have to call someone up, get on the phone, and work through it. It was a nightmare. Fast forward now through today. Totally different model we're dealing with. And most of you in the room, yes, being younger, you're like, yeah, this is what we knew, this is what we grew up. If you're under 30, this is probably the world you've always known. But you have to understand that to get here, right, people had to build this stuff and get this moving and get this grooving. I'm talking data volume in terabytes, petabytes, exabytes, and it's a world where everything is immediate, okay? You think about, all right, let's pick an app, Snap. Think about Snap at New Year's Eve, right? Snapchat, click on it. How many requests do you think they get in a region at New Year's Eve? Like you're talking in the millions all at once, right? How do you handle that? Think about football game. You think about like the Eagles won last year, right? Think about like the shirt for like some storefront, right, that has Eagle shirts. Bam, how do you get hit like that? It's massive. And everyone expects it to be on demand all the time. Your mobile phones, you're looking at it now. You look on your Facebook page, you're going other places. Everything's instantaneous. It goes somewhere. We all know that. What's the database? Where's the data? Where's it going? So we need systems that are going to be able to scale and get up to speed quickly. Other thing here, too, is now we have the new world, instant API access, which is a big deal. Because now developers, people that want to build, the new builders, they want instant access so we can do it whenever we want. It's just assumed. If I go out there now and I don't find like my answer right now, I'm with Stack Overflow immediately, or I don't have an API, I'm going to go searching somewhere else. And that's just the way it is. I think it's fantastic, but it's a lot to keep up with. So 3 key drivers of evolution. This is, I talked on this a couple of years ago, actually, and it's fantastic because this is like even more so now. But I view it like a flywheel of 3 things coming together, and this is my personal opinion. The perfect storm of open source coming into be, right? Let's get it out there. I can do it better, or we can do it better, and let's work on it. Let's put something out there and then get other groups of engineers, other computer science graduates, other folks with great minds to come build and help us build this out. And then mix that with the cloud now, in which, now we can actually put this up online, have people access it, play with it, and we can share in real time. And then, not just that, but the rise of the builder, the idea of the new developer, and also the idea of community, right? People that are out there now that are learning, they have free access. And when I say open source, it's not just open source databases, open source languages, open source applications, right? That mixed with the fact that there's communities, there's information, and there's this medium of the cloud and cloud computing that can help people to get it done. And that has been seen over the last, I would say, 10 years that has gotten us where we are today, and it's not slowing down. See, the truth in that and the proof in that is just look at cloud computing over the last 5 years and the businesses that have merged, AWS included, as well as all these other ones too as well. But it's very important to think of this. There's 2 books, and I hope most everyone here have read them. If you haven't, you should. The New Kingmakers and The Software Paradox. It was all written, Stephen O'Grady, one of the guys who started at Red Monk Consulting. If you guys haven't taken a look at those books, they're fantastic. Software Paradox is a little bit more recent. The first one is a little bit older. It's like 2013, I think. But they chart the course for a lot of things that are today, and I think they're fantastic references. So purpose, the reason for which something is done or created or which something exists. All right, I'm gonna back away from computer stuff for a second and just kind of go through this idea of things being built for purpose. You probably know where I'm going with this anyway. So things with purpose. I got an idea here, okay? Let's back up, let's talk trucks, okay? Trucks are pretty good. If I'm gonna give you a purpose, I'm gonna give you, let's say, some kind of goal or some kind of a challenge. If I said, I want you to take 2 mattresses from Raleigh to Chapel Hill, which truck are you gonna take? Most likely, I hope you're gonna take the pickup truck, because that's gonna be the most comfortable for you and also the easiest to carry those mattresses in. But if I say to you, okay, I need you to take 50 mattresses from Raleigh to Seattle, which truck are you gonna take? So you see where I'm going with this now, right? We're going into which tool is right for the best job. Think about the Amazon Fresh truck, right? That's really good for taking food in and out real quick through city streets that are quite narrow. And then think about the big giant mover truck that could be like building something for RDU Airport, right? All of these things have a purpose in mind. It's not one size fits all. And that's something to think about here as we look at this open source adoption, as we look at cloud adoption, as we look at the new builders, these developers. Think about how that all comes into play. Now, if you don't like trucks, there's other examples of this as well, right? You think about everything you use in your own kitchen or at home, right? Do you cook spaghetti in a frying pan? On average, I hope not. I've done it once. It's not the best way to do it, but sometimes it calls for it. But it's like, think about your knives, your cutlery. You're gonna cut your turkey, with like a butter knife? No, probably not. You're gonna use a sharp knife, ready for carving. Golf, you're gonna drive balls with your putter? I hope not, right? There's a lot of different examples here. Right tool for the right job is another one. But have this idea of purpose in mind. And this is what I'm going to ask you too, as you think about building new apps and doing new things, right? You start with what you want to achieve, what you want to accomplish, and then work backwards from there. Which is actually the next slide. I'm a little ahead of myself here. But it's true, right? Don't go starting something out and being like, I'm going to go attack this with the tools I currently have if you don't have to. Stop and think what you're going to fully need first, and then do some research on it. Go into some chat groups, some help areas that you can actually get access to, like, hey, we had the same problem and we use this tool or we use that tool. And that can help you on your journey, and trust me, you're going to be way better off in the long run. I mean, I have way too many stories that I know of without getting into specifics of, hey, I'm a developer. I'm using this database because it's super quick, it's cheap, and it's fast. I don't have to use too much. This happens to me a bunch when I work on hackathons. Because like, hey, why are you making us use a relational database or use this database? We're challenging you. And they're like, no, we need to use this one because it's super fast and super quick. The problem is, though, it can only take you so far. Because the next part of the hackathon might be, now we want you to run BI queries on this. Like, I don't know where the state is on this. I don't know where my data is. I just know it can scale real quick. You got to look at the purpose and work back from there and pick the right tool. So I'm going to go through a couple. This is high level. Some of you folks in here could probably take me into the weeds on some of these. But think about the different types of data stores that are there, all right? And I'm going to go pretty agnostic. I'm not going to get into the weeds on specific Amazon or AWS services, even though we'll have some in there just so you can have reference points. But let's talk through some of these different data models that exist today. I mean, one of them is the relational database, right? That's the tried and true. That was originally there. Referential integrity, ACID compliance, right? These things held state. And there's a reason they did. And there's a reason they're still here, and we'll get into that. But there are some limitations to it, specifically in this new world order. You have key value stores. I love key value stores. Different type of model here. Scale up really, really quick. They don't have all the different constraints that relational databases do. We'll get into that too. Document data stores, also super great. When you start thinking about content, thinking about blogs, thinking about web pages. JSON documents are a totally different way to go. In memory, it's a little bit different. This is a little bit more AWS focused on in-memory, but how if we took some of those key value stores, instead of leaving them on disk, we put them into memory, and they're there, and they're waiting for you. Caching, okay? It's super, super important as well. And the last one, now we're starting to move into some of the new emerging areas, graph databases, and others. And this is not fully exhaustive, right? We have a limited amount of time here. But these are just some of the areas we can start thinking around how we think differently around data stores and data models. So I'll go through some of these, and I'm not trying to be boring here. I'll try to go through these kind of quick. It's not everyone raises their hand like, yes, databases, the most fun in the world thing to market. No, but the relational database, right? If you think about it, it serves a purpose, and there's a reason why it's been so great, so powerful. And if you think about this, let's look at a regular ledger, okay? If, let's say me and I have someone, Joe, and I own the book, and I'm gonna record, I have $1,000, Joe has 100, and I'm gonna pay Joe $1,000. So I record the transaction, give it to Joe, $1,000 more, and then, in the time 3, he's got all his money, I've got nothing. And it's the perfect recorded transaction. If I own the control of this database, I'm the one hitting this, I don't really care about a relational store, right? I can just record whatever I want. Now let's think if Joe and I both have access, or you have access, you have access, you have access. And you're also changing, the ledger. You're also changing what the payments are. You start seeing where we start getting into issues here, right? This is where ACID compliance and this is where referential integrity come into play. The basis for the relational database. Awesome, great, game changer. But do we always need this? Every single thing we build? The answer is no, we don't. Can you build with these? Sure, but you're not necessarily going to want to. Here you're looking at how things are created, right? These databases were normalized. And when the relational database first came out, they were really made for how it was stored and for disk. Disk was the resource of the time that was scarce. So how do you store and group these together? Look at this scenario, right? It's great. This is fantastic for finances, perfect for transactions. Okay, things in which I want to maintain state. I'm going to put a credit card through. I'm going to do an order form because it maintains state, maintains integrity across the entire process, and makes sure no one screws it up in the process. Right? Super good, super great. But what if you want to scale really quick? Is that always going to be there? No. What's happened? A lot of these databases, people got mad at relational databases because they tried to scale super big, and they didn't do the right things to the database. Okay? They tried to then, how do we cluster this on different systems? How do we break this out? Nightmare. Cloud has kind of helped that out a little bit, and some of these other data models that we'll get into. Oh, and just a quick one out here too. Columnar, I'm throwing that into relational, even though sometimes people can review it as a different store, because essentially it is a relational database. It's still storing relations, but it was one of the things around data warehousing to get things faster, right? We grouped them a little bit differently. So let's say, all right, in the last one, we're having a store here, and I'm selling pencils, erasers, papers, pens, and all your great, office supplies. This is fantastic. It's my Excel spreadsheet of death. But if I really wanted to take a quantity, right, of what are all the different quantities here, right? I have to look at every single row. And this is a simple one. Now think if you're doing this in the tens of thousands, right? You got to look at every row. That's dangerous because every time you're pulling from a row, if you're potentially changing it, you got to slow down the system, yada, yada, yada. Right? So what do? Turn on its side, and we group them together. Right? And this is Columnar data stores, why things like the data warehouse appliances of years before, they still are kind of, but data warehousing in general, Redshifts like this as well from AWS's perspective. Still relational, a little bit different, being Columnar. Oops, added animations. All right, key value stores. Do people know what key value stores are or not? When I was learning this for the first time, it was like the best way, and I'm totally dumbing it down here. but I always thought it was like a bus locker. It was like you had a key and it was a locker, and I could put whatever crud I wanted in there. And I didn't care what it was. And that was awesome because we think about all the different structures you're going to try to fit in a relational database that aren't going to fit. A key value is fantastic because I can just throw whatever I want as a developer and get it in there, and then instantly, as long as I got that key, it'll return it. Super good. Also, hold that thought then when you go through in-memory caching as well. Key value stores have also gotten a lot more robust, doing a lot more around it, and they can store different types of data structures as is. But these are what you want to use if you want to scale something really fast, really quick, really big. Fantastic for it. And here's an example, just real quick if you weren't aware of key value. This is actually from our docs. Sorry, it's a little bit faded there. But the key you use here, right, they're inside the table. Say it's a people. You have a key, personal ID, one-on-one. As long as I have that person ID, and that's the primary key, I can pull out anything I want in there, okay? Any of that data. And it doesn't have to be the same, right? It doesn't matter because this one here has zip code and the other one doesn't have zip code or it has a different code in London. If I was going to throw some of this into a schema-full relational database, you know, it would kind of stink, right? In the sense that, like, if you didn't have the schema, if you weren't prepared for it, you could be sitting there all day trying to get that data in. If you're trying to build something quick for internet scale, key value stores are going to save the day, all right? Granted, if you're going to be doing BI reports and other things like that later on, I'd think first about that because a lot of developers have gone this route and then later on said, we probably should have put some of this in a relational database. But again, getting back to what's the right tool for the right job. Document stores. Take the key value and then mix it with, I kind of view it a little bit like relational and key value, but the idea of a document now, right? So take a JSON document, take a web page, take the example around having different metadata around a document, all right, JSON. And then creating a key, you know, the key is actually in the document that you can search from, but now you can actually search through the doc. It's not just like a locker where you put a lock on it, I'm not sure what's inside there until I open it up. I can actually search on the data that's within that document, which is actually this example here. Think about how easy this is written versus actually looking within a relational store, okay? In memory, and I talked before about key value. Now let's take a key value, something like Redis, Memcache, others like that, if you've heard of them before, like really simple key values and put them in a memory. That's a cache, okay? Now all of a sudden, think about, I'm on a web page, and go back to the Eagles example. Hey, Eagles win, you know, Super Bowl, and let's say I sell sports memorabilia, right? And my website's getting killed because everyone's looking for Eagles, and every time it's doing the search on it. When instead I could just pass up that, hey, Eagles done, because basically that key is Eagles and it opens up the cache and it shows me the web address. All right, very simple example. I like keeping it simple for myself. But another area that pops out, think gaming now. All right, let's emerge from Larry's land of lame, you know, old school, you know, web page visits to the world of gaming. Okay, which I don't have any time for anymore. My God, I got like little boys, and all I want to do is play games, and I'm like, I can't even play anymore. I don't have time for it. But leaderboards, right? How do you keep, like, say, in these massive multiplayer games? How do you keep something like Fortnite, right? How do you keep the leaderboards? How do you keep everything up to date in real time? You can't store that in a relational database per se, but if you leave it in cache, you can always update and update for the next player. And so these are some of the techniques and some of the areas that people are leveraging in kind of the new world order of data stores. This is just a very simplistic way of viewing it. You know, you think about it, you don't have disk anymore, you don't have the storage engine. It's all super speed and super quick. And then you have graph. Graph is another one to get your head around. Does anyone here actually use graph databases? This would be an interesting one. All right. This is a little bit more on the forefront of the next frontier here, but relationships. When you store data, it's not just the data itself. You're storing the relationships to that data. And you think about it as you traverse a graph for recommendations. Like, think about it like, I know all of you now. You know me. And we have a relationship one-on-one. And you start looking through, it's like 6 degrees like Kevin Bacon. What was, you know, like, if you think about the things, how many people know someone else, think social media, think fraud detection, the relationships that are involved between that. You don't want to have to go looking and go back to the old picture. I wish I should be able to flip back and forth between the relational databases. You don't want to look up everything in that relational database. You would like to just be able to look from node to node and see that relationship, who's there, and count them. Well, here's an example, right? So this is one of the things, Kindle books would be a perfect example. Netflix, all the recommendations that say, hey, you know, Larry, this is what you read, this is what you looked at, this is someone should be your next friend. These are all many times based on graph algorithms and graph databases. And so you can see here kind of, this is the relational formulation of it versus what it could be in graph, in which it could just be a nice, hey, I'm the employee, and I work in this department, and I know Steve, and Steve knows Jill. And instead, it's just one traversal rather than 400 different ones. And it's super, super good for doing these type of solutions. Anyway, high-level summary, because I was trying to prove a point here and illustrate, look, we have a lot of different tools out there, right? And it's purpose-built, meaning we can all decide which tools we need, right? You're not supposed to just walk in and be like relational databases versus all or key value stores versus all. As developers, as computer scientists, as technicians and engineers, right? You all need to know you have the ability to pick and choose whatever you want, okay? And pick the right tool for the right job. I look at here, we've got a slew of different offerings, and we're not stopping under each one of these, and our competitors do as well. But start looking at it. Start trying to figure out what are those type of problems you want to solve. You know, if you're doing ERP, are you doing finance? Do you want to do relational, social media, relation graphs? Think through the different models that are there. Take a look at what's in the environment and work back from that. I'll give you a couple examples here in real time, right? Or not real time, but in real life. Airbnb, right? Everyone go to Airbnb before? So you go to Airbnb, you look at all the different properties that pop up there, right? So what are they using behind the scenes? So they are a customer of ours, and this is how they do some things. You know, think about it for their search history. If I go in there and they look, hey, Larry's been looking at these properties in Raleigh, he's coming to visit, right? And then I go back to, let's see, Seattle, and I live there, so I wouldn't be looking there. But let's say I go to Canada, I'm looking at properties there. They're going to maintain my search history and where I've been and what I've looked at in Dynamo, which is a key value store. They're able to look that up. It's a massive data volume because how many people here are hitting that every point in time, right? They have to be able to handle internet scale for the amount of people that are going to come hit that site. They need quick lookups on the personalized search that are going to associate to my ID. So for their session state, so when they want to look at site rendering, if they want to look at price updates or things for you in your actual state right there, they put it into cache. All right, I'm not sure which version of Elasticache they use, but they do that, which is either Redis or Memcached. And then transactional data, they use RDS, which is our relational data service. Love acronyms. And that's where they actually do the transactions. So if I actually want to take one of those houses and say, I'm going to put my credit card in, I'm going to pay someone, they're not putting that in a key value store, they're putting it into a relational database. You know, tried and true as we looked at relational database, the benefits of it. Another example, Expedia. So they use a number of these other services as well. And so what they do with some of their pricing, and when you're going to Expedia and you're looking for properties, right? Sometimes you might see an ad, it might be like, hey, Larry, you know, you got a super quick deal, you know, $100, you can stay tonight. You know, they want to know, okay, first of all, is that price right? Is that $100 right for me? And if I click on it, right, they got to make sure it's proper. But say if I look at it later on, right, or how does that affect my search, right? They want to keep a little bit of a track on that. So they do it in real time. They actually bring the real-time stream processing in through Elasticache, through the caching model, to be able to handle that. And that's what the 24-hour look-back window is, be able to look back at those ads and look at what I picked or did I choose or not choose that property. That data then gets put into two different types of data stores. Transactional data gets put into Aurora, which is the same as a type of RDS. We'll get into that in a second. Operational queries, and then the data warehousing, the Columnar, gets put in for Redshift. So just using a couple of these quick examples, and I'll put links to more, like some that are later on, like a lot of architecture series if you're really interested in this and you want to see companies that are live doing this, what they're picking, what they're choosing, and the problems they're facing. I got perfect links for y'all. You can go look and just listen to customers talking about how they're building these new objects. But what are the benefits? You know, hopefully I'm nailing this one down for you because I firmly believe in this. It's going to offer you better performance. Okay, if you're going to build an app, you're going to build a program. You know, by being able to actually step back, pick and choose, and make sure that the right tool is doing the right job, you're definitely going to get better performance. You're going to get better scale as you grow. Who knows if your app's going to take off, right? Say it doesn't, great, you never really know. But say you do, and it's like, oh my God, I could have made $1 million on this, but I didn't because I screwed up and didn't actually build it right. You're not going to want that because you're going to have a limited amount of time when something takes off and it's going to hit. You want to make sure that you're structured wisely. More functionality, this just goes with the case. I mean, caching is going to give you caching functionality versus something like a relational database. It's easier to bug, true, right? If you know what the type of database it is and it's only looking at a caching platform versus every giant whole honking, database, you're going to know where to find it a lot easier. And then also you're going to be able to break up between teams as well, as needed, and like focus on certain areas. That gets a lot more important when you're actually doing distributed workloads and you're distributed programming together. You can work on a piece, someone else can work on a piece and bring them together. Anyway, a mouthful. It's a lot of good stuff. So, what happens to relational database? Because I'm kind of tearing it up here, right? Relational database, oh, it's bad news, and it's difficult to use, and it's a pain. Not true. The relational database still has a lot of importance here. So, you think about this. We talked before about like the commercial databases that were there, right? A lot of people, this is why the open source movement took off. A lot of people are like, oh my gosh, it's too much money. It's costing us a lot. As we're growing or scaling, I got to pay more money in relation to that. And people are getting frustrated. So some of the open source engines started becoming more popular. This is just a limited amount. MySQL, Postgres, MariaDB, and others. 2 of my launches today, actually, too. They're moving to them, but they want some of that commercial element. They want something in which some of those commercial databases brought to the table, right? The open source, sure, I mean, it's mature now, but if you have organizations that are building like millions and millions of dollars of research into certain functionality that customers and corporate enterprises are asking for, yeah, you're going to miss some of that sometimes. This year, I'm not trying to do a sales pitch or anything like that, but I want to tell you, this is one of our kind of pride and joy elements here, or software, is Aurora. Aurora is our database that we built for the cloud. So we essentially said we like the commercial engines and what they're doing, and we like the open source aspect. Let's put them together. And let's actually structure a relational database that can scale with the cloud. A couple of things here. I'll get into RDS in a second, relational database service. But you're going to get faster performance, and I'll show you how that's done actually with some of the way we're distributed in the network. It's fault tolerant. How if you had self-healing storage? Something starts going wrong, it fixes itself. That's really cool. There's also a thing called backtrack. Say you screw something up, like everyone makes mistakes. I make mistakes all the time. Know any mistakes I made in this presentation or trying to do it on the plane? Kidding, I did some of this before. There's a backtrack function. Press a button, at a point in time, rolls you right back. Fixed, done. Oh, great, problem averted. These are things that we're building in. Very secure, that goes to be saying encryption at rest, encryption at transit, and it's fully managed. And this is something that, specifically at AWS, we're super proud of, is that we fully manage these databases. You can take any database you want today. I don't care, whatever one, you can put in EC2, which is our compute platform, and you can manage it yourself. DBAs love doing this because they have full control, right? But a managed database is a little bit different where we're doing that hard stuff for you. The patching, the updates, all that jazz you really don't want to be doing anyway. So with that being said, this is fully managed as well. So how does this work? Well, I mentioned before about the availability zones and the regions. So with Aurora, what we allow you to do is you still have your primary reader. So this is the primary read and write. This is the main instance that you're going to be worried about. And how are you going to want to scale, let's say, if you're someone like Expedia, right? And you've got everyone from around the world hitting your website. You can actually create read replicas across different availability zones. So replicas of your database that are optimized for people to read that data, right? The transactions are going to have to somewhere else, but they're going to have super fast read access to the point of scaling up to millions of reads per second. This is on cloud, and I date myself when I think back to the 9800 baud modem I had, right? You would get nothing like this. But these are entire businesses being built on it that are going at kind of the speed of light here. And that's how Aurora works there, and they actually share the storage across the entire flow. That also allows you then, think about a failover, something breaks down, right? Well, now all of a sudden, say the master node in the availability zone goes down, this one right here, for whatever reason, who knows why. You'll set up read replica 1, will turn back on, it'll take over for you. Because all the data is actually persisted right there in the distribution storage volume, it's all ready to go. Okay? And if you're pointing at the right place in that database cluster, instantaneous access, you basically don't skip a beat when it goes down. That's awesome. And that's kind of what we're looking at here. I want to share with you relational databases that are a little bit more cloud ready, internet ready, that can scale and handle the demands of this massive, massive workload. So a couple of things I'll share with you that we're super excited about, and I was happy about launching this last year, or actually we pre-announced it last year, and actually it came GA this year, Aurora Serverless. This is really great for, let's say, test dev. Right? Aurora is a very, very powerful database, or transactional database. But what if I can put on there and say, aha, I'm a developer. I don't know if my app's going to take off. I'm going to go in there. I don't want to deal with the servers and all that kind of stuff. I just want, here's my min and my max. And you know what? If people start hitting my website and it takes off, I want you to scale. But I don't want to pay for it. right? If it doesn't go off, I only pay for storage. That's serverless. So for test dev environments, for things that we don't know, that are unsure of, right? Instantaneously, it'll actually scheme and grow back. It'll expand and grow as needed. And when you're not using it or people aren't hitting it, you're not paying for it. And this is new for us. And this is a new area of computing that allows a relational database now that we talked about, the old guard, still just doing some new stuff. And it's evolving for the cloud economy. And I can get into like more too. Like I don't want to bore you, but we actually have, there's a pool of buffers that are out there that are just waiting for it to scale. So that's instantaneous. It's just waiting for something to happen to your database. And when it does, it pops right in there, starts transferring that data. Here's another one that's in preview. It's multi-master. As I mentioned before, like, hey, you have a primary that can only do the reading and writing. Multi-master is going to allow every single one of those read replicas now across the board are going to be able to do reads and writes. Right? So now I think about those transactions. You're not just reading from the database, you're able to update it as well in the cloud. And that's in preview mode today. This is a quick example of one of the companies last year that came over and migrated over to Aurora, and actually Aurora Postgres was Verizon. They had a whole slew of different databases they were working on their own. They had things that were like, they had Postgres in-house, they had some other commercial engines in-house, and they brought them in, and they fully moved over now too as well to handle, to be able to take care of some of these higher volume items. And Aurora is actually our fastest growing service in history. So the relational database is not dead. It's actually super important across the board. So I don't want anyone walking out of here saying, oh, Larry said the relational database is gone. It's not. It's still uber important. And this kind of proves that fact as well. I also can't leave you this, Amazon RDS. So Aurora is not the only relational database. RDS is a relational database service, and we actually handle even competitors and these commercial engines we're talking about. We have databases that are managed, fully managed for developers and businesses. MySQL, Postgres, MariaDB, SQL Server, Oracle. Yes, we handle them all. And we have people that on their migration path that want to go and try something like Aurora, or they're building some new app, like many different databases. They're like, we don't want to switch over today. Let's say RDS SQL Server first and stay on that. And we have plenty of customers that are super happy, right? So it's not like trying to tell you you got to pick and choose one of these things. We have a lot of different options for a lot of different customers, and it's really what tool is right for you, what database is right for you. And again, just to kind of prove the point, yes, we have a lot of people using this. This is not a small service. And I know it's like on the 45-minute mark, I think, about. So I want to give you guys and gals some takeaways here, some things in which you can hear me, great, Larry talked a lot. Where can you go to find out on your own? Because I think the most important thing about being a builder, being a developer, being in computer science is you have the tools at your disposal to go do the research and get hands-on and listen to people. The best thing that I tell you to do, listen to customers talking about their challenges. Listen to other developers, the things that they've failed with, the things that they're working on and building with. We have a series on AWS called This Is My Architecture. This is awesome, because what we do is we just interview casually leads and organizations and talk to us about your architecture. What are you building with? What are the challenges you faced? What problems you run into? How did you solve those problems? And you start thinking through some things you might be wanting to do, whether it be now or later on. I mean, this is just one resource. It doesn't have to be just Amazon. It could be anything out there that you can go to and kind of test and see, what is right for you. Just to prove the point on some of the databases here. RDS and Elasticcache, BuzzFeed are leveraging two of these stores. Vanguard, using Dynamo and RDS, as well as a couple other solutions there as well. Very, very much purpose-built, all right? Not one-size-fits-all kind of mentality. Zodoc, as well as London Stock Exchange. And these are just a few that we just picked in for this just to show you, so we had some slide gravy here. But there's way more out there. There's a lot more. And I totally suggest you check it out. Now, this is one that's near and dear to my heart, and I throw it out here because we have a free tier, and a lot of our services are free. Anyone can go play with and work with. Aurora is not free. It's not in the free tier. But we've started a challenge. I have a hackathon going on right now. If anyone here is data savvy, I think there's like 15 days left. We're giving out credits and prizes and all that kind of neat stuff. And if you win, you get featured on our website, and we'll talk about what you built and neat stuff like that. There's like, there's probably like 12 more days or something like that to submit. But it's there today. It's aurora.devpost.com. And so if you have any interest in any of this stuff or you want to challenge yourself, go check it out. Because what we'll do is we'll give you a bunch of free credits up front. And if you can build something, you get it. And there's already like 460 people that are doing this. And we're going to do more of these. So if you want like more opportunities of this, please email me, because I'm super big fan of like hackathons and getting hands-on. like see what you got. Win some prizes, and if you get selected, then we'll bring you on, we'll do a podcast with you. Or do you guys know what Twitch is? Like, so we own Twitch, and like I didn't understand the whole thing with Twitch where, you know, people were actually watching other people play video games, which I do now, but we actually leverage it as a platform for talking to developers and experimenting with new technologies or new ways to build. And so we're actually looking at whoever wins this challenge, you're gonna come on, we'll do Twitch interviews with you, and we'll record it, and you can come show your skills and show what you built. A couple other resources. If there's anything that I talked about here today, if you're interested in databases and data in general in the cloud, the number one resource I would say is Reinvent, and that's our big conference that we do every year. And if you want to hear our CEO talk about what I just talked about, like our 2017 is up there. Is anyone here going to Reinvent this year at all? Totally go. I mean, it's like, I've never seen an event like this. Last year was my first year I actually went, and it's insane. It's just one big giant party of just learning. And all the experts come out with their wares, and it's like almost like a builder's fair where people are just coming out with their code, and they're like, this is what we did. You know, come on board, we're gonna show you more. I would say is, you know, if you ever want to hear the latest and the greatest things that are coming out, there's a lot of great announcements that always occur during this point in time, so Reinvent's always a good time to listen up. Werner Vogel is Amazon's CTO, and so not just AWS, all of Amazon. And he actually wrote an article very similar to the content I presented here today, kind of underlining some of this purpose-built story, all right, and the importance of, as a developer, having the choose and having this at your fingertips. And then another link here is AWS Databases. We need to update the site, but this essentially is all the different databases we have in one location, and you can kind of look real quick and be like, yeah, which one should I need? Which one should I use? What's right for me? It's a good place to start. I'm going to tell you right now, we're going to be building this out even more so, getting a lot more resources, a lot more demos, tutorials, and you know, feel free to reach out to me. You know, let me know if there's anything you wanted to find out, or if you didn't hear about today or could find in the direction. Just ask me. We can point you in the right direction. That's it. I'm going to pose it to Q&A now. I think I got about 10 minutes, and then if I miss anyone here, then we'll go afterwards. So,
thank you.
Yeah.
All right, for Q&A, we've got a couple of our ambassadors. Where are they? Okay. So what I'd like to do is if you raise your hand and just wait until you get the microphone, state your question in the microphone. We want to make sure we capture it on video for everybody else. So where's the first question? Okay, back here to this gentleman.
Hi. So you mentioned that some businesses like to use the cache databases. Mm-hmm. I was wondering how long is that data typically kept there until it's like deleted or something on average?
Many times it's up to you and the way you want to set it up, right? So if you're going to keep it there, and I'm not the expert in this, and I'm talking full, all the caching capabilities that are out there. It really depends. It also depends on two things. Number one is what kind of data you want to store in there. You're going to create some crazy long like JSON document you want to store in the cache, or is it just like quick, you know, binary data that you just want to pass in and out? It can be anything from like seconds, microseconds, through, you know, keep it 24 hours and longer. It's really up to you. And I would say that's one of the things when you start looking at which database is right for you, you know, figure out what you're going to want to keep and for how long it, and then study the market and see what's right.
So Amazon was more or less like first to market with their infrastructure as a service model, with in the wake of like Google and other people coming after that to take some of your market share away. How are y'all preventing that from happening? Like, what new ideas are you coming up with that are distinct, I guess?
Well, I said go listen to Reinvent. There's a whole slew of things. I only cover databases here, and there's a whole lot of areas in which that I don't even have expertise in, that the company is pushing to new boundaries. Everything from AI, ML, speech processing. Like I'll give you a cool one too. My kids love this. Like there's a service called Poly, and it's just small, but it's like you can just type in and like, it'll read it back to you, but in different languages and different accents and stuff. I gave it to my kids, and they're like losing it. They're like, "Oh, Dad, how many bad things can I say and make it say it back to me?" Really, what we do is we listen to customers, right? And I didn't really get into it in this presentation as much, but everything we do, okay, is customer and then work backwards. And that's kind of where the backwards thing comes down to. So the things that we're building in to, let's say, Aurora, or building other services, and things you might hear in the future that are coming out, are specific things that customers have asked for and said, hey, AWS, I don't have this right now. Can you do this for me? And then we build that in. And you'll see that if you actually look at some of the announcements through the different services, that's how we're doing. And so I would say one of the key things we're doing is we're innovating, and we're innovating based on what the customer demands are. But I would also say, too, just from a fun perspective, if you look at the amount of solutions we have in those areas, there's a whole number of experiments we're running at the same time. Yeah, and you'll see more of it. It's the pace of innovation. I'll give you this, and this is like a personal note. Coming into this company has been phenomenal. Like, it's just the amount of tech that you touch and the amount of like good people that know this stuff, it kind of blows your mind. And it's a challenge to keep up, specifically with like my marketing brain, right? Because there's so much great stuff. I mean, how do we palletize this? How do we make it so it's tangible and it's actually a customer benefit sometimes? And it's a challenge, but it's definitely customer driven, and it's definitely innovative first.
Yeah. So,
Where are we? Oh, cool.
so about the Aurora Serverless. So is it like based on Lambda, or is it like a separate service altogether, or is it, so my the question is probably like, is Aurora Serverless very brand new, and is it based out of or uses Lambda in some way, or is it just a separate service
At this point in time, it's brand new. I mean, it just came out at one of our summits. We GA'd it. We announced it last year. I would say at this point in time, it's basically a standalone product as a database, as Aurora. And the fact it's serverless is the fact that it scales compute and storage automatically based on what you put in there. But from a programming perspective, interactive, it doesn't have like integrations at this point in time.
For Aurora, for your multiple write case, how are you keeping the different databases consistent? Because that's where you start losing your scalability if you're locking every time you're writing.
Yeah, so that to be announced when we GA, because I can't go into that right now. No, that's in preview mode right now, and it's one of those things. I mean, I would say feel free to knock on the door and check it out. But that's one of those things that is to come. And just a quick point too is when these things do come out though, like I love being hands-on, and I love making tutorials and demos and things that are making it easier to people to learn and play with this. On the serverless note, we actually do have a full-on tutorial that allows you to get hands-on and kind of learn and feel from scratch. So it's on our site now. It's been there I think for about a month now, but feel free to check that out. But yeah, the biggest thing is a lot of this stuff is until things are GA. Stay tuned.
So is there any particular component with any of the DB products you've made that specifically enables Alexa or anything involved with that, or any particular one that sort of specializes for that?
So now you're getting me off guard.
I know that's more machine learning stuff.
No,
but
I can look that up for you. I can find that out for you. I don't want to give you the wrong answer. Yes, I don't know the specifics. I could guess, but I could let me know, and I could follow up, and I can get you that answer. But yeah, we do eat our own, or we drink our own champagne, yes. And a lot of these technologies were actually, think about it from an Amazon.com, perspective. That was like our, yeah.
Yeah, exactly. That's the question I'm going to ask. What about Amazon.com? Yeah. So from the Alexa question, I'm actually going to ask, what about Amazon.com? What do you build that upon? I mean, what kind of facility or services do you utilize with that?
Sorry, what services we use on Amazon.com?
Right, exactly. So you said you use your own, basically you use your own tool set.
Yep.
And
Yeah, I don't know all of the different ones, but things like Dynamo. Dynamo was created in part because things weren't scaling. There were servers that were on relational databases, and some things needed to scale very quick and very fast. And that was one of the first services, that we had in that world. So. But yeah, I mean, this is, I can get you a list of the open technologies that we're leveraging for these as well. But yeah, we do use them. I don't want to tell you something that it's switched over because I don't maybe the latest and the greatest on it.